Welcome back to the channel where we unlock real PC performance. Today, we're diving deep into the invisible world behind your frame rate, graphics APIs, DirectX 11, DirectX 12, and Vulkan. If you've ever switched APIs in a game and wondered why one feels smoother but another gives more FPS, stay tuned. You're about to find out why that happens and how to fix it. We'll fine-tune your Windows, GPU driver, and registry for each API type, safely, cleanly, and effectively. Let's begin. Understanding APIs. Before tweaking, let's understand how each one works. DirectX 11. Stable but CPU heavy. It depends on threads and draw calls handled mostly by your processor. DirectX 12. Low level, fast, but inconsistent if the game isn't coded well. Vulkan. Balanced, lightweight, and efficient across all brands of GPUs. Our goal isn't to pick a winner, but to tune your system so that each API runs optimally for your specific hardware. Clean and rebuild shader caches. Let's start simple, clean caches. These tiny shader files build up over time and can cause stutter during gameplay. Open command prompt as administrator and type WPR cancel. Then restart your PC. Windows will rebuild clean caches the next time you run a game. This small step alone can fix random lag spikes during level transitions. Registry optimization for DirectX cache. Now let's tweak how Windows handles shader caching. Open Regedit navigate to hay_local_machine/software/Microsoft. Right-click and make a new key named Direct3D. Inside that folder, create these dword values. Shader cache equals 1. Shader cache size equals 0x40000000. Shader defrag equals 1. This enables persistent caching, sets a 1 GB shader limit, and ensures regular defragmenting. If you ever want to undo this, just delete or reset them to 0. Nvidia Control Panel Optimization. Now we match your driver settings with your API type. For DX11, Threaded Optimization on. Low Latency Ultra. Power Management Max Performance. Pre-rendered frames 1. Texture Filtering High Performance. For DX12, Low Latency off. Power Management Normal or Optimal. Shader Cache on. Triple Buffering off. For Vulkan, Threaded Optimization Auto. Power Management Max Performance. Shader Cache on. Anti-aliasing Transparency off. Each of these settings syncs CPU and GPU workloads to minimize queuing and stutters. Command prompt and scheduler tweaks. Next, let's tune the system clock and scheduler for consistent timing. Open command prompt, admin, and run. bcddit/set use platform clock true. bcddit/set disable dynamic tick yes. bcddit/set sync policy enhanced. Restart after running these. These commands tighten timing between CPU and GPU threads, improving stability and latency. If anything feels off, revert with the delete value commands I shared earlier. Vulkan specific boost. Vulkan runs validation layers by default, great for developers, but unnecessary for gamers. You can disable them by creating a new environment variable. Disable_Vulkan_validation equals 1. This helps reduce background logging and slightly improves frame time consistency. Driver level async tuning. Let's go deeper, async compute. Modern GPUs process graphics and compute tasks together, but if async scheduling isn't tuned, you get spikes, where one thread waits for another. Here's what to do. Open your Nvidia Control Panel Manage 3D Settings Global. Scroll to CUDA, GPUs, set it to your primary GPU only. This prevents Windows from spreading compute load across unused cores. Open Nvidia Profile Inspector, free tool. Under Frame Queue Limit, set 1 or 2. This ensures that your GPU processes draw calls and shaders in sync, giving you smoother animation and less render delay. If you're on AMD, open Radeon Settings Graphics Async Compute equals enabled. That helps Vulkan and DX12 games balance workloads efficiently. Background process balancing and final tips. Even with perfect GPU tuning, background processes can choke performance. So, here's how to balance Windows background tasks. Press Win+R, type sysdm.cpl. Go to Advanced Performance Settings Advanced tab. Under Processor Scheduling, select Programs instead of Background Services. Disable or delay telemetry tasks. Press Win+R, type tasks.msc. Navigate to Microsoft Windows Application Experience. Disable Program Data Updater and Compat Runner. These run in the background and consume CPU spikes. Once disabled, your game threads get priority access to CPU time slices, improving 1% lows and responsiveness. Finally, ensure game mode and HGS, hardware accelerated GPU scheduling, are both on under graphics settings. This lets Windows hand off rendering queues directly to your GPU. Testing and comparison. Now test your setup. Use a game that supports multiple APIs, like Doom Eternal or Horizon Zero Dawn. Record gameplay in DX11, DX12, and Vulkan using CapFrameX or MSI Afterburner. Focus on frame time consistency and 1% lows, not average FPS. DX11 should now feel tighter, DX12 smoother, and Vulkan more consistent. And that's it, your PC is now API tuned, scheduler optimized, and driver balanced. You didn't just boost FPS, you built a stable, latency optimized system that responds faster than ever. If this video helped, hit like, subscribe, and drop a comment with your results. I'll feature the best setups in the next episode. Next time, we'll go even deeper into GPU scheduler tuning and interrupt balancing to make your GPU and CPU talk like a real performance pair.
I won't let me quit. I swear that